Hey guys, welcome back to another episode of Simuleos. Today is going to be an absolutely fantastic day, like I'm 25.5% sure. Thanks for coming in, guys. Sorry about starting a little bit late. I know it's 5:22 in the morning. This is 22 minutes past the time I normally start. But I think we can still get everything done in an hour and 30 minutes, which is the time I typically end my stream. So we'll see how that goes. Hebrew Hammer, Lost Center, thanks for coming in, guys. I really do appreciate it. So let's go ahead and get started by opening up Zernal and going from there. So, Zernal, here we are here. Now, what are we doing? Well, we are taking all of the bad events that happened in 2016, and we are sorting them with the absolute worst sorting algorithm imaginable. Now, here's the thing. We've already done BOGO sort. BOGO sort is pretty darn bad. I mean, like, all you do is you randomly jumble everything until eventually you get the answer you want. That's pretty bad. Okay. Now, the worst... Yeah, we're going to do bubble sort first. That's actually what we're going to do next. So the first thing we need to do is bubble sort, which is what we have, let's see. What we tried to do yesterday, but I forgot exactly how it works. It's actually relatively straightforward, and I'm kind of kicking myself that I forgot how it worked. Here's what we do. We say, it's basically just two for loops. We go through, and we switch all, sorry for the on. We switch all of the adjacent elements. So the idea is we go through the array, element by element. So we go 1, 2, 3, 4, 5. And if one element is in the wrong place, we just switch it. So here we have a list of all of the, let's say, elements in the array. Something that looks like this. I don't know, something like this. Okay. So we go through and we say, okay, well, these two would need to be switched because... Oh, actually, no. These two would not need to be switched. But these two would need to be switched, because this one's larger than that one. And then afterwards, these two would need to be switched. And then it would be in the appropriate order. So then you say, okay, well now we check to see if it's sorted again. If it's not sorted, we go through and we try it again. So we basically just keep going until this array is sorted. So while this is not sorted, we just go through and we just switch all the elements. And that's literally all we need to do. It's actually relatively straightforward, and I apologize yesterday for being an idiot with this one. In my defense, it was the last 10 minutes of stream, and I didn't think we would get that far, but that's okay. After this, we're going to introduce worst sort, but let's go ahead and get bubble sort done first, and then we'll introduce worst sort, because there's a few different functions that we have to create. And in the paper that I'm looking at right now with the worst sort stuff in there, we have a whole bunch of things that we can do for that. So we'll see how this goes. I'm hoping it turns out okay, but, you know, worst comes to worst, it doesn't. We'll see. Okay. So let me go ahead and put this up, and let's just go ahead and get started. I know there isn't that much of a reason to have Zernal up. I just wanted to mention this is what we're doing first, and then we're moving from there. So pop this over there, and that over there. Now CD, the projects, Simuleos. Yes, I sure can. And then worst sort here. Let me CD over here. Okay. Let me go over here, and let's find that link. So it will be at how inefficient can a sort algorithm be? Okay, here it is, and there we go. Okay, so that's the link for worst sort. If anyone else asks, I can very easily find that, so it's not very hard to get. Okay, so now let me do a quick ls here, and let's go into worst sort, if I can spell VI right, worst sort dot cpp. Pop down to the bottom here, and let's go ahead and manipulate our bubble sort algorithm here. Okay. So this is what we have right now. Function to sort array based on bubble sort. Okay. So first of all, this isn't quite right, but it's not actually so far off of what we need to do. But the algorithm that we have right here, the worst sort paper. Here, let me just go ahead and go to that paper right here, PDF. The paper actually has a bubble sort in there that we need to implement. So I figure, why not? Let's just go ahead and implement that bubble sort. Now, obviously, this is the archive. It's not properly edited. I think... Unless I'm really, really wrong here. I think that bubble sort is spelled with two B's. But that's okay. So we say for I equals 2 to length L, do this. For j equals 1 to length L, minus I plus 1, do this. So we do, basically, if these two are less than the other, we swap them. That's all we need to do. So I guess we're just going to go ahead and do that. Now, what did we have up here? We said first for size key I equals 0, actually this is not very far off what we need at all, so let's go ahead and dd that, and then let's dd that. So we say if array less, we swap, then we plot the bar graph, and then we increase the current frame. Okay, so we're going to say for I equals 0, I less than array.size, j less than I. Let me see. It should be, yes, j less than I. Okay, and then we should do, if array j, sorry about that. Let's say j here, and let's do j minus 1 here. It doesn't really matter which ones we're comparing, I suppose. So now we do j and j minus 1. Okay, now let's see. Does this make sense? So we're going through, and we're saying I equals 0. So we're going through the first element. No. So this has to be, we have to start at 1 if we do j minus 1. Now the other way we could do j plus 1, and we just do a minus 1 at the end. So let's go ahead and start these at 1. There. Let's go over here, and let's make that. Okay, now what we're going to do is not j less than I. Wait, why is it not j less than I? Let me see. Oh, it's j less than, sorry about that, array.size minus I. Make. That's what we need. So now we're going to do worstsort. Thanks, Lost Center. Okay, give it a second to do its thing. And now let's do Mirage. Okay, so here we have all of the bars being created. Somewhere in here, I think. Wait, where are our bars? Oh, there they are. Okay, so we have these guys, and we should see, yeah, that one. Oh, I'm missing the very last element, aren't I? Okay. Yes, you're right. Okay, so now let me think. I'm missing that very last element. Let me look at this one more time. Let's scroll back down. Okay, so we have all these guys. We have this element here is brought to the side, like it should be, but then this guy should be, it should be not there. Okay, so why are we missing that last element? Okay, it could be. Let me see. So we're going through all the elements. If array of j, let's see, array of j is less than array of j minus 1. Yeah, we can add a +1, but this doesn't solve the, I mean, it will solve the underlying problem, but I'm trying to figure out where the problem comes from. I mean, one second, let's go ahead and do worstsort. Mirage. We're gonna have to scroll back a little bit. Here we are. Okay. So that one should be brought to the end. Yeah, I mean, this does solve the problem. Okay, so now why do we need a +1? That's the question. And actually, let me go back to the last Mirage command, and let's look at 0, 0, because this is a little bit easier to see. Okay, so now we have the sorting happening exactly like it should. Now, there's one thing that we need to do, and that is highlight the bars that we're switching. And I would like to do this. Let me think. Yeah, I would like to do that soon. Just give me a second to think about this. Okay. So what I need to do, why do we want a +1 there? We need to go through all the array elements. If there are 9 array elements, yeah, okay, that's fair enough. Yeah, because I is going to be off by 1. Okay, that's good. Okay, so now what do we need to do? We have bar graph here, but there's one more, how do you call it? One more function that we wrote the other day, and this function will be, let's see, there's worstsort there. So let me go ahead and do a quick ls of, actually no, let's go into one of the files of visualization, Cairo visualization dot sure, go down here, and the function is called highlight bar. So what I want to do is highlight 2 different bars, the 2 different bars that we are looking at for one particular frame, and that is the frame in which we are comparing those 2 bars. So let me go ahead and create a a new line here. So let me go ahead and undo that last one. So let's do yank paste, and this is going to be called highlight color. And we're just going to make those red. So let's go ahead and do an R0, R0 here. Okay. Now what do we need to do? We do bar graph. So we plot all of them. And then after bar graph is being plotted, what I want to do is I want to compare the two. Yeah, so it has to be after bar graph. So we're going to do highlight bar. And we're going to have to highlight two different bars here. So we're going to want anim int start frame. And this is going to be anim.currentFrame. And then we're going to want to do anim.currentFrame plus 1. Okay, now what's next? We have to do the array itself. So it's going to be array. Then we want to do x range and y range. So it's going to be anim.resolutionx and anim.resolutiony. Okay, now what do we need? Resolution y, x range, y range, color, highlight color. So then we want highlight color, color, CLR. And then finally we want the bar that we want to highlight, which is going to be J. And then we're going to do yank to yank. And we're going to paste this down here. And this is going to be J plus, J minus 1. Okay, so let's go ahead and do a right quit, make this guy. And hopefully, when we do worst sort, we see what we want. Okay, let's do the last mirage. Okay, we're comparing these two, these two, these two. Yep. Okay, so it seems like this is actually okay. Yeah, the red's kind of hard to see, but that's okay because when we do more bars, this will be a little bit more obvious. So let's go through and let's go ahead and do more bars just to kind of, you know, get this guy working. Let's pop up to the top. How many bars do we want? We want, let's do 50. Make worst sort. Okay, give it a second. Oh, okay, did over 500 frames. Let's do 25 then. Make mirage. Oh, I'm sorry. Worst sort. Now let's do mirage. Okay, so let's scroll down. Yeah, so here we have these guys being... Yeah, okay. This looks okay. Yep. Obviously, worst sort is not the best sorting algorithm. So, like, there are better algorithms that we can use. But it does okay, you know? Yes, it does okay. Okay, so let me look at this one more time. And, you know, there is something that I find a little bit off-putting about this, and I can't quite place my finger on what it is. But again, I'm sure if we have more elements, we can make this look even better. So we'll kind of keep that in mind. Okay, so now let's start talking about worst sort. Because worst sort is really bad. Like, it is awful. And it took me a while to figure out how awful it was. It wasn't until, like, last night that I realized how awful this is. I mean... Okay, so the idea behind worst sort is it is provably the worst sort possible. Now, when we say provably worst sort possible, of course, people may come up with worst sorts that are worse than worst sort in a bit. But for now, it is definitely the absolute worst possible sort possible. Okay, so here's what's done. Let's go over here, and let's say we have a simple array. Page, new page before. Okay. So let's say we have a simple array. Okay, this array will be, let's say, 3, 1, 2. Okay, so we want to sort this array. Okay, well, to sort this array, we know that this array will be some permutation of these 3 elements. So what we can do is we can say, okay, well, we can take, oh, let's change the numbers here. Let's do 7, 6, 9, or something like this. Okay. Okay, so what we can do is we can say, okay, well, this right here is either going to be 1, 2, 3, 1, 3, 2, 2, 1 second. Oh, wait, 2, 3, 1. Basically, it's going to be some permutation of these guys. Or let's see, 3, 1, 2, 1, 3, 2. Let me see. Okay, but you kind of get my point, right? Or maybe you don't. So 1, 2, 1, 3. Let me see. It's going to be some permutation of these guys right here. So in order to sort this guy, you create all of the permutations of this guy, right? And then after creating all the permutations, you then list permutations of their indices. Yeah, exactly what you do. So you say, you know, you list all of these indices up, you list all the permutations, and then we have to sort the permutations. Okay? So that's basically what we have to do. So we create the list of all the permutations, then we sort the list of permutations. Then after sorting the list of permutations, well, we're done. But the issue is, what algorithm do we use to sort the list of permutations? That's a pretty good question. So the algorithm we choose to use is worstsort. So what we then do is we take this list of permutations and we pretend that it itself is a new element. So let's say, let's see, if there are 3 of these guys, this means that our list of permutations will be 9 in size, right? So then we have all of those permutations to list. And then after that, we have to say, okay, well, now we have a new list of permutations. Let's sort these, put them in lexicographical order. And by lexicographical order, I mean, we just have to go from there. We sort them because this way we have a defined way to go through all of the elements. It's kind of, so for example, BOGO sort. BOGO sort, let's do, we did this one yesterday. So BOGO sort has a 1 over basically n factorial chance, I think it's n minus 1 factorial chance, of being in the array. So let's say BOGO. And BOGO sort, again, is the one where you basically just randomly shuffle the array again and again and again and again and again and again and again until eventually you have found the array you want. Okay, so that's the BOGO sort. It has a 1 over n factorial chance every shuffle to be in the permutation, or be in the, permutation we want, be in the order we want. However, this is, if we choose, instead of just shuffling at random, to shuffle through a defined like list. So we say we shuffle first this way, then this way, then this way, then this way. We shuffle in a defined way every time. So we go through the list of all the permutations. This goes from 1 over n factorial to something that we can actually get a class, what is it called? A big O notation. So, what's the word? Complexity. So we can actually find the complexity. So if we go through an ordered list, we then say, okay, well, we can now do this in O n factorial, and that's at least possible. Like, so we now have a complexity case for it. So in the sorting, we make it a little bit easier to find this complexity case or something like that. That's the argument behind it. But in actuality, I think they're just grasping at straws here to make sure that the worst sort is by far the worst sort possible. Can't we have all indices sorted earlier? Can't we have all indices sorted earlier? For BOGO sort or for worst sort? So we can do the sorting, I suppose, when we create the list of permutations. But let me see here. Yeah, we could do that, I think, but I'm not sure exactly the best way to do that. We'd have to do some sort of sorting once we create the list of permutation at some point, I think. But again, the point here is that this is provably the worst, since the indices are known before. We probably could, but again, the idea here is to do the absolute worst sort possible, right? So we don't want to optimize this. We actually want it as bad as possible. And following from the paper, they show that this is actually order of, and they use omega instead of O notation, but it's basically the same thing. This is just the best case instead of the worst case. And it's going to be 3 parentheses, dot, 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 n factorial, dot, 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 factorial, factorial, squared. And that is the, that's the complexity. it's awful if we do it this way. And again, the idea behind this sorting algorithm is it's the worst of the worst sort. So everything you're doing is somehow moving you closer to getting your sorting done. However, it's pretty bad. It's pretty bad. So that's kind of the idea. It's kind of a silly idea, but at the same time, I mean, this video is supposed to be kind of like a silly-ish video anyway, so I'm not so worried about it. It's just kind of for fun. More or less, it's a celebration of 2016 in a way. But everyone's been saying 2016 is the worst year possible, so I figured we should do the worst sort possible. And that was kind of the idea. So that's kind of all we have to do here. Anyway, guys, sorry if this is not the cleanest description. I think it'll become more clear as we're actually doing the programming. For now, I'm going to get a quick sip of water, and then we will kind of go from there. There's a couple of different functions we're going to have to implement for the worst sort algorithm, but in the end, once these are implemented, it should be relatively straightforward. And then we have the question of how we're actually going to sort, or how we're going to visualize the worst sort algorithm. And this I have not quite yet decided, because in every sort, we basically have to sort. Let me see. So, yeah. So we basically create all permutations. And in order to sort each of these guys, we have to create all the permutations. So let me see. This becomes really, really difficult to visualize. So what I might do, I might spend tomorrow finding a better way to visualize this. And then we'll kind of go from there. Because I have an idea of how I want to do it. I just haven't quite yet figured out the best way to make it look. So I'm going to have to kind of make something up for that. But it should be okay. Anyway, let me go ahead and get a quick sip of water, and then we'll keep going from there. Okay. So as far as the functions are that we need, let's go through. Actually, you know, today's technically a day off. Yeah, it's quite similar to how you visualize a recursive function, right? But the issue is I don't know. So here's what I'm thinking about doing. I'm thinking about putting, let's see, new page before. I'm thinking about putting the central array in the middle. So we'll do the array right here, 1, 2, 3, 4, something like this. And then we create all the permutations of this guy. So we would do, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, all these guys kind of around this guy, Probably another guy over there. And then we take each of these guys and we split them up. Maybe I'm doing a bad job here, but the idea is that we split them up in this way. So that's going to be relatively straightforward. But the question is, and I know this is kind of a silly question, but the question is, I guess, as we go further out, how do we visualize each element as they get smaller and smaller? If that makes sense. So we have the ability to draw a bar graph on basically any arbitrary point. Yeah, this should be relatively straightforward. I think we can get this done. Yeah, it'll take some time, but I'm pretty sure we can get this done relatively straightforwardly, I think. Oh, crap. Dropped my pen. But that's okay. Okay. So we're going to work on that tomorrow. I think we'll get the worst sort done today. I'll go ahead and get all the audio up and ready for the video that I will hopefully put up tomorrow afternoon. Because again, today is a day off for work, so I have, I don't have all day to do things because I end up spending a lot of time like reading papers and things like that, but I can go ahead and get the audio and stuff done, and that should be pretty good. So, looking forward to that. Okay, let's pop over here. So what are we going to do? Let's go ahead and get the worst sort function started. But before that, we have to create a whole bunch of auxiliary functions. Bah, I can't say anything. So let's pop over here. So one function that we're going to have to do is actually a less than function. Okay, and the less than function is going to be kind of a little bit weird. So let's go over here, and let's see. We're going to have to do two different functions here just to make things a little bit easier. So we have bubble sort there, and what I want to do is the following. So I want to do, let's see, we have bubble sort. So let's go ahead and go up here and say necessary functions for worst sort. Okay, so worst with a T. Okay, we're going to do a T there. So the first function we need is going to be Boolean less than, and this is going to be for basically two integers, I suppose. So we're going to int I and int j, and we're going to say, just put it up here, and we're going to say return I less than j. There we go. No big deal there. This should be relatively straightforward. In fact, let's just go ahead and put this in parentheses here. Okay. The reason I want to do this is so I can pop down here, and in the bubble sort, instead of doing, where's our less than that we have in the bubble sort here? What I want to do is the following. I want to do less than here, array of j. Oh, actually, one second. I just realized. It's going to be a vector of integers array. Yeah, okay, so there's no reason to do this one, actually. Yeah, we're going to have to create a separate bubble sort for the worst sort. Let's go up here. 1. Okay, so this was unnecessary. My bad, guys. I was thinking that we could use the same function, but the more I think about it, probably it's better to just create an overloaded function for the bubble sort algorithm. Yeah, probably best to do that. Okay. But we will need to do a less than for these guys. So let's go ahead and do a less than. 1 second. For Boolean less than, and we're going to need two different guys, a and b, and these are both going to be vectors. So let's do an std vector of integer, and we're going to say a, and std vector of integer, and we're going to say b. Okay, and we're just going to go ahead and define that down there. Another function that we're going to need, we're going to need a bubble sort for this guy, but we'll get to that when we get to it. Now we need another one, which is going to be I guess std vector. Now here's where I'm not really sure how we want to return this. We could do a vector of vectors, but I don't really like that idea. But it might be the only way to get this done, doing a vector of vectors for all the permutations. This might be how it is. Sorry about that. So maybe we should do it this way. Because we need a list of all the permutations. So each list of permutations should be... Yeah, I'm not seeing the best way to do this one, but that's okay. So we'll say a vector, and then for now, I'm just going to put a vector of vectors, but we'll kind of go from there. std vector of integer. Yeah, permutations. I guess we'll just call it perm. And what we need to read in is an std vector. Oh, okay, this is actually not... I suppose a vector of ints should be okay. And we'll call it list L. I'm following the notation from the paper. And then finally we need another function, which will be a multi-level sort. I think this is going to be a void. 1 second, void multi-level. And actually, guys, they say we have a multi-level sort up here. But actually, this multi-level sort is literally just worst sort. So what I might just do is call this worst sort that is already defined down there. And we should be okay to go from there, I think. So one thing we also need to read into worst sort is some sort of depth or something like that. So let's go and do an int depth, which they call as k, but I'm calling depth because it makes a little bit more sense to me. And this is basically where we're at. So let's start with the less than. So again, the idea is that we're going to sort these guys in what's known as a lexicographical order. So the idea is that if we have a 1, 2, 3 in one vector, and then a 1, 3, 2 in another vector, the 1, 2, 3 is less than the 1, 3, 2, if that makes sense. So the idea is that we want them in the natural counting order. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. So let's go ahead and do that. So we're going to pop down here, and we're going to say, let's say auxiliary. Say spell auxiliary functions, right? Functions for worst sort. Okay, so first one is going to be Boolean less than. And again, I'm pulling this from the paper that I just linked. If you guys want me to relink it, feel free to let me know. And we're going to say, what was this going to be? An std vector of integers, and it will be, I think, what do we call it? A, and then we want std vector of integers, and we're going to call that one b. Pop down there. Okay, now what do we need to do? We need to go ahead and get this done. So what we're going to say is the following. We're going to say for k equals 0. Why k? Why do they do k? Let's do I. I like i's. I equals 0. I less than, what do we want to do here? I suppose a and b should be the same size. So first, I suppose what we should do is we should say check that a and b are the same size. And let's go down here and let's say if a dot size let's do not equals to b dot size. What we need to do now is we need to assert that a dot size equals b dot size. And I'm going to output something real quick up here saying std cout the array sizes are not equal. You screwed up. Okay, there we go. Done. New line. Got it. Okay. So a dot size equals b dot size. This should be okay. Do we have assert being read in? No, we do not. So let's go ahead and go down here and include assert.h. Okay, now let's pop down here again. So we have this. We're going to say I less than a dot size because they're both the same size. And then we're going to do I plus plus. Pop down here and add a new line there. So what we're going to do then, let's change this to a size t. Add a space there. Checking each element to make sure that, I guess, they are all less than, I guess checking each element makes enough sense, right? I suppose that's okay. So we're going to go through each element of A and B, and we're going to check to make sure that they are all less than, right? So let me see. What do they do here? They say for k equals 1 to length A, they return, they say if A is less than B, we return true. Okay. Otherwise, we return false. Okay, so here's the idea then. We're going to say, because we're checking whether A is less than B, we're going to say if A of I is greater than B of I. So if any of these guys is greater, we're going to pop down here and we're going to say return false. Okay, because then it would not be false. And otherwise down here we do return true. Okay, so the idea is if we can get down to this point, okay, if we can get down to this point, we should be set. So what I want to do is I want to go ahead and test this function real quick. So yes, I'm going to go ahead and test this function real quick. So let's go up to the top here. We have main here. What I want to do is I guess just comment out most of this main stuff, in fact all of the main stuff, and just read in 2 vectors to that function we just created, and just to make sure it works. Okay, so here's what we're going to do. We're going to say std vector of integers, and this is going to be, let's say a is going to be equal to 1, 2, 3. Should be okay. Hit paste, and now we're going to do b, and that's going to be 3, 2, 1. It's going to be 3, 2, 1. Oops, screwed that one up, didn't I? 3, 2, 1. Okay, so now what are we going to do? Let's go down here. Let's do std cout, and let's do less than a, b, new tab, and then we're going to do less than b and a, new line. That was not how you do new lines. There we go. Let's go over here. Let's make that. Fix all the bugs. Oh, there were no bugs. Interesting. 0, 0. They're both 0. That's incorrect. 1, 2, 3 should be less than 3, 2, 1. Okay, so let's check to see what the issue is here. G down here. So if A is greater than B of I, let me just go ahead and see out if we ever go in here. let me do an SDEC out. In a condition, exclamation mark, make worstsort in a condition. So it gets in the condition both times, but the question is why? It's a super good question. So if A of I is greater than B of I, which should never be the case, so let's go ahead and output A and B. Let's go here and let's do A of I, new tab, B of I, new line. Yep. Let's go over here, make that. Do some worst sorting. There we go. 3, 1, 3, 1. Why is it comparing 3 to 1? Both times. Both times it compares 3 to 1. A and B. Pop up here to the top. Oh, A, B? Wait. Let me think here. So we're comparing A to B the first time. Yeah, no, that's right. We should be comparing A to B one time and then B to A the second time. And we should be saying that one is less than the other. Wait. Yeah, no, that's right. Okay, so why is it comparing 3? Why is A 3? A should not be 3. Oh. Gotcha. Let me think here. Okay. But... Yeah, I think that puts a kink in my plan, doesn't it? Okay, so I gotta think here. What they do is they say if let's see. They say if crap, now I have to think about things. So they say they actually read it back into the less than algorithm, but they're reading in the integers. So let's see. They say if A is less than B, then A of K is less than B of K is what they write down. How about you define if a permutation is lexicographically less than another? That's what I'm trying to do here, actually, and that's what I did incorrectly. So let me think. How do we do that? So we want... So obviously 1, 2, 3 should be less than 3, 2, 1, right? Because that's kind of what we're doing here. So I suppose... Let me see, where's their less than algorithm? We say for all the elements, we check. Yeah, let me just take a look at their paper. So here's what they do in the paper. They say, here's what they have for less than. They say k equals 1 to length a, do the following. They say if a of k is less than b of k, we return true. Else if b of k and a of k, then we return false, okay? So this means we're going through all of them. Yeah, this seems to be what they do. A of k is less than b of k. Okay, so let me think here. Oh, I'm sorry, Lost Sender. I misread your statement. You asked, how do we define if a permutation is lexicographically less than another? And that is exactly what we're doing here, so the answer remains the same, but I do apologize, I misread it. Okay, so we say k equals 1 to length a, okay? We do if less than that. So what do we need to do then? Again, the idea would be that 1, 2, 3 should be less than 3, 2, 1. And we know this because basically what they do up here is they say they have a list. Where's the list? Here's a list, and they want to sort this list in 1, 2, 3. Oh, sorry. 1, 3, 2. Okay, so that's kind of like what they want to sort the list into. So all the 1s are at the start, then we have the 2s, and then we have the 3s. Okay. So that's kind of the order we want it to be in the end. We want it to be such that we have the ones up front. So it goes 1, 2, 3, 1, 3, 2, then 2, 1, 3, 2, 3, 2, then 3, 1, 2, 3, 2, 1. That's kind of what we want. Okay, but now the question is, how do we do this? And that is a super good question, guys. What I say we need to do is we need to determine that 1, 2, 3 is less than 3, 2, 1, like what we did before. So 1, 2, 3 here should be less than 1, 3, 2. That's what we need to figure out how to do. So how do we say that one's less than the other? Well, going the other way, wait, 1, 2, 3. Okay, so at some point in this permutation, right? A is larger, or the first one is larger than the second one, right? That is totally true. Because at some point, like what we just showed, 3 is larger than 2, right? So that's exactly what just happened before. Okay. So, dang. How do we do a lexicographical sort, I suppose, or a less than function? They have it here, but I'm not convinced by it. It doesn't seem to quite work the way I want it to. So we say if A, K, B, K, then do return true. That is true. Whichever array has the lesser element first is a smaller permutation. I see. Yeah, you're right, Lost Center. I'm getting it now. Okay, so basically the idea here, it's kind of subtle, or at least it is to me, maybe not to you guys, maybe you guys you already get it, and you're banging your head against the keyboard because I'm doing this incorrectly, but here's the idea. Okay, so let's say we have a couple different permutations we want to check. So we want to do 1, 2, 3, we want to do 1, 3, 2, and then we want to do 3, 2, 1. Comparing 1, 2, 3, 2, 3, 2, 1. It's obvious at the first element that this one is less than this one because 1 is less than 3. So we just return true. But at this one, 1, 3, 2 versus 3, 2, 1, 2, 3, we have to compare not the first element but the second element. So because we already have this in a for loop, we skip the first element, right? We just completely skip the first element. And then after skipping the first element, we check the next one, and then we return true. So, okay, these guys are right. I just took a little while to think about it. I'm going to have to put in some comments, but I get it. This is fine. Okay, good. This is what I get. This is what I get. So let's go down here. We say if A less than B, a greater than B, then we return false. But we need to do the following. We say if A of I is less than B of I. So basically, if there is ever a point when these two arrays are not equal, then we go from there. So we're going to do return true. And if we get to the end here, we're going to return false. Okay, so checking each element. And let's go here and let's say until a pair is different. Then we return the I suppose value for A of K or A of I less than B of I. If we get to the end, all elements are equal. Okay, there we go. Something like this. Okay, this I think will do it. Let's go over here. Let's go ahead and make. And then we're going to do worstsort, and we should get a 1 and a 0. Good, and that's exactly what we get. Okay, pop up to main. Good, so we have these guys set. That is good. Now, what do we need to do next? Next, we need to do the permutations. And this is going to be a pain in the butt. Okay, so let me think about how we actually want to do these permutations. So the idea is that we need a list of lists. And that is fine, I suppose. I'm not liking this permutation function at all. Like, I get how it's going to work, but at the same time, man, I am not happy to do this function. Okay, so I suppose what we need to do is read in a list of lists. No, read in a list, and then return back a list of lists. That's what we need. So what I'm going to do is I'm going to pop down here, and I guess we're just going to go ahead and get started with the function. So let's go ahead and grab the permutations here, which is just going to be called perm, and let's go. So function to find a list of lists for all permutations. This is gonna be awful. Let's pop down here and let's do it. So we say permutation of int L. So basically we're reading in L. I don't know why it's called L. I'm just following the notation from the book. Maybe we should call it something else. But that's okay. So let's just go ahead and do it. Okay. So what we need to do is we need to say, first of all, if, let me see, if the length of L is less than or equal to 1, so we're going to say L.size is less than or equal to 1. We're just going to return, gosh darn it, that was all kinds of bad notation. Could you manage it all in a single vector? Or just manage the way you address them to mimic a vector of vectors? Yeah, see, that's what we're going to have to do in the end. So, this is why it's going to be kind of a pain. So I don't like the fact that we have to use, or that I have written down a vector of vectors, but I can't think of a way to do it otherwise. Because here's the situation we run into. So let's do page, new page before. Okay, so if we have 3 different elements, right? Let's do 3 different elements. We'll say the following. So we'll say 7, 6, 9, like we said before. Okay. We read these in. So this is element 1, 2, and 3. And the list of permutations is 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 2, 1. 3, 1, 2, 3, 2, 1. Okay. List of permutations. Okay, that's 6 of them. Okay, so this list of permutations. I mean, what we can do is we can say that we have a block dimension of 3. So we say, okay, so the first 3 elements will be our first permutation. The next 3 elements will be our next permutation. The next 3 elements will be our next permutation, so on and so forth. And that's fine. To address these elements, we would have to have some sort of we would have to have some sort of way to access this underlying array. So we'd have to find some way to basically grab like the elements of each of the elements. So it basically turns into a vector of vectors anyway. And then we run into the other problem, because this now turns into a vector that we access as 1, 2, 3, 4, 5, 6, right? And then to find all these permutations for the next order, it's going to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6, 5. 1, 2, 3, I don't know, 6, 4, 5, so on and so forth. So we have all of these permutations to do. So it ends up just becoming really, really crazy at some point. So a vector of vectors of vectors. Yeah, that's the thing. Like it's actually a recursive vector. And we're already playing tricks by turning it into a vector of vector. Oh man, this is so bad. This is like the worst. sort of algorithm. Oh man, this is awful. But it's okay. It's okay. Remember, the point of this is to make the worst sort algorithm possible. It is the absolute worst. That's the idea. It has to be the worst. So this is okay because, you know, I'm kind of waving my hand and saying, well, okay, I would never do this in a real situation, but because this is worst sort, I can get away. You know, it's like, I suppose, a potato chip or something like that. How, you know, you never really want to eat a potato chip, but you can. So let's go ahead and go in here and let's say, worst in terms of like everything. It's awful. Because like the permutations just keep increasing to the point that eventually you have like millions of permutations you have to go through to sort sort an array of size 4 or something like that. Actually, I'm really looking forward to this video because of how crappy this algorithm is. It's the best. It is the best. In terms of the worst. It's the worst, but also the best. Like, I don't know, it should just be a lot of fun. Like, that's kind of the point, just to have it fun. Okay. So, let me see. As far as the video is concerned, press list would be a better option? Yeah, we could, but we already have all the visualization in C++. So I say we just keep going with C++, and we go from there. I'm not going to worry so much about getting this done in other languages, just because, again, it's going to be harder and harder to do the visualization stuff in those other languages. So we're going to say if l.size is less than or equal to 1, that means that we're at the last element here, and what we need to do is the following. We need to say return. Let's go up here and let's say yeah, so I guess we're going to do std vector of std vectors of integers, and I guess it's going to be called p for the permutation, and we're going to return, we're going to say p dot append or pushback l, and we're going to return p. Okay, there we go, done with that case. Now for the more complicated case. So here's what we're going to do. We're going to say we already have p defined, and now we need to say, I suppose else here. Okay, so now we have p defined, and we're going to say for size t, I equals 0, I less than, let's do l.size, then we're going to do I++. I can't type at all. Okay, so let's pop down here. Okay, so now we're going through all the elements, and what do we need to do for each of the elements? So what we need to do is create a separate vector up here, which they call L1. So we're going to do std vector, and we're going to say of integers, and this is going to be called L1. I'm not a big fan of this notation, but that's okay. So we're going to say L1 equals L, okay? Now, what we're going to do is we're going to remove an element in L1. So I think this is going to be, let me see, how do we remove elements of a vector? We can do this in a number of ways. We create our own function to do this, but I think there's already a remove function in the vector. So let's do remove from a vector. C++. I think it's just remove or something like this. Vector.erase, is that what it is? Yeah, okay. So we'll do L1.erase, and we want to do, yeah, just one element. So it's going to be L1.begin, and then we're going to do plus I. Okay, so now we have that set. So the idea is that we remove this element from the array and we permute L1 now. So now we just do all the permutations of L1. And we go ahead and define a vector of vectors, which is called p naught, and that will be that. Okay, so let's go up here and let's create p naught. Okay. So now we're going to go down here. We're going to say p naught u. P naught is going to be equal to the permutations of L. 1. Yep. Okay. So we do all the permutations of that guy. Then what we do is we say for size t, j equals 0, not 90, j equals 0, j less than, is it L dot size or L1 dot size? Oh, it's actually p not dot size. Then we do j plus plus. Okay, and give me just a second to finish writing this, and then I'll describe exactly what it's doing, because it's not quite obvious what it's doing for a lot of people. But let me just pop down here. It's actually not so bad when you look at it, but it's not the best. So now we're going to say p p dot append. 1 second. So first of all, we have to create the list that we're going to append, and this list is going to be L1, whatever it was before, or L, whatever it was before. Let me see. So it's going to be, crap, I gotta think here. How do we append to the start of a list in C++? C++. Oh, I guess insert. Obviously, should have been what I did. So let's see. We want to do insert at the iterator. And so what we're going to do is we're going to say myVector.insert, and we insert the value. So we're going to do the insert now. So we're going to say, okay, we have a list of permutations, p naught. Oh, this is complicated as crap. Okay, but let's do it. Let's do it. We got this. We got this. We got this. Okay, so we're going to say p dot pushback and we're going to push back p naught of j dot insert at p naught of j dot begin, and the element that we want to insert is going to be L of I. I think that's right. I think I forgot a parentheses, but I think that's right. Okay. So we're going to push that back. And then at the very end here, after everything's done, all the dust is settled, we're going to return P. Okay, so what is this doing exactly? Here's what this is doing. So we do page, new page before. Let's start with a random list of elements here. So we'll say, again, 7, 6, 9. Why not? Let's do that one. Okay, this turns into 1, 2, 3. So we have 7, 6, and 9. 7 is going to be the first element, 6 is going to be the second element, 3 is going to be the, or 9 is going to be the third element, okay? So now what we do is we say, okay, well, we're going to go through each of these guys, and we're going to stick 1 here, and then we're going to permute these guys here. So now we do all the permutations there, and we say 2, 3 is going to be one permutation, 1's here, and then 3, 2 is going to be another permutation. Then we go through here, and we say, okay, well, the next time what we're going to do is we're going to keep the second element. So now we do, the next one is going to be 2 at the start, and then we do the permutations on 1 and 3. So it's going 1, 3, and it's going to be 2, 3, 1. Then we keep 3, so 3 is going to be at the start, and we do the permutations on 1, 2. So 1, 2, 2, 1. And that's basically what we're doing here. We're going through each of the elements, we're removing one element, moving it to the front, and then what we're doing is we're permuting all the other guys. So it's kind of a recursive permutation function, but hey, I think it should work. So let's go ahead and implement this guy, and hopefully we'll be okay. I don't know. We'll see what happens. So let's go down here, and let's just go ahead and output everything. So let's go to the top. We have this guy. We can go ahead and keep this in here. So now let's go ahead and put a quick comment in here. Say testing the not permutation, less than function. So now we have to do a test for the permutation function. Okay, so what are we going to do? Let's go ahead and create a vector A. A is already created, so we can just go ahead and keep this guy. And what we want to do is we want to say std vector of std, one second, vector of integer is going to be p. It's going to be equal to perm of A. And what we want to do is output this, so we're going to say 4. And I suppose we're going to say size t, I equals 0, I less than p dot size. Yep, there we go. And then we can do I plus plus. Pop this down here, and then we're going to say 4. If I can spell 4, size t, j equals 0, j less than p of 0 dot size. And then we're going to do j plus plus. Pop this down here. And we're going to say std cout. And we'll do p of I of j. That should be about right. New tab. Yep. I think that should be okay. And then we're going to do an std cout new line. New line. Let's go over here. Let's make it. Okay, so we had a couple of problems here. Let me see. No matching call for std vector pushback. Let me see. Insert. Let me see. P naught of j dot insert. Let me see. Did I do something wrong here? Pushback. I think, unless I'm doing this really incorrectly, let me just do something real quick. Let's do the following. So just to make sure, I feel like I'm doing this insert incorrectly, but I'm not sure exactly how. So let me go to 185. And let me see, we have this insert over here. So we're going to do my vector insert here. So we're inserting this guy at my vector.begin. See, where are we? Insert, iterator, 200. Okay, iterator is my vector.begin, so that should be okay. But it doesn't seem to want to do anything, so let me think here. The vector of integers, our integer, over here, is L of I. New match recall std vector, integer, pushback, std vector, integer, iterator. Why is this an iterator? Let's pop over here. My vector.insert. Cout for my vector.begin, my vector.end, cout iterator. Do I just need to do a dereferencing guy? Let's check here. I don't think this is the case. Let's make that. Yeah, okay. Didn't think it was the case. Okay, so what I'm going to do then is I'm going to go ahead and comment all this guy inside here out. And I'm going to do a quick test real quick. Let's go up to the top. Let's see, here we have it there. And let's just go ahead and comment out this permutation test real quick. Let's do a quick test for the insert function. So we're going to do a.insert. And what do we want to insert? We want to do a.begin. And let's do 4. Now we want to do 4, size t, I equals 0, I less than a dot size, and then we're going to do I plus plus. Pop down here. We're going to do std cout, and we're going to do a of I. New line. Make worst sort 4 1 2 3. That seemed to work just fine. Okay, so that means that wasn't exactly the issue I thought it would be. Let's go ahead and comment this out. Comment this one back in. And let's pop down here and let's see if we can figure out what the problem is. Okay, so we say for size ci. So the issue is in this p. So it's p dot pushback p naught j. Okay, so p naught of j is going to be a vector of integers, and in p naught of j, we are inserting at the very first element L of I, and L of I should be an integer. So let me just go ahead and make this again. Sorry, I think I just hit the microphone. Let's go ahead and make this again, and let's see what we get. Okay, so no matching function call for std vector integers, pushback, std vector integer iterator. So why does it think this is an iterator? Let's see, insert p naught j dot begin L of I, insert's fine there, pushback. Let's just create L1, let's create L check. Let's go down here and let's do L check. So we're going to say L check. It's going to be equal to this guy right here. And then we're going to push back L check. Make that. Okay, where is it breaking? No mention call for operator equals. Okay, so why does it think it's an iterator? That's a stupidly good question. So p naught is a vector of vectors. Okay, so I think the issue here then, if p naught is a vector of vectors, then p naught of j should be a vector. Yep, that's fine. Maybe this should be a p naught of j. No, that is a vector. So it should be, okay, because this should be a vector of vectors. I think it doesn't like that you're applying a pushback on a vector of vectors. But that should be okay, because we have this done up here. Let me see. Besides, the issue is now coming in this L check function, so creating a separate list. So for some reason, this guy is returning an iterator when it should not be. And also, I forgot a semicolon. Let's go here, let's make that. Okay, no match for operator. std vector of integers and std vector of integers iterator. Okay, so again, it's returning back an iterator when it shouldn't be. P naught is a vector. How do I check this? How do I test this? L check is equal to p naught j dot insert p naught j begin L of I. Man, I feel like chat is super quiet today. Do I even have, yeah, there's like no one watching. Does anyone even know I'm streaming? Ah, it's fine. Okay, this is fine, I guess. Okay. I mean, obviously there's Lost Center. Thanks for coming in, man. Okay. So I'll check is p naught j dot insert, p naught j dot begin. Let me see. No, you're fine. I just, I find it weird. Let me check something real quick. Can I just refresh this page? Yesterday we had like 25 people watching, and today we have 5. I don't know what happened to everybody. Huh. No, you're good. Thanks, Lost Center. I appreciate it. Yeah, is there something wrong with the stream, maybe? No, I guess it's fine. Huh. Okay, well that's bizarre. Maybe it's because I started so late? Could be. Huh. Okay, well let's just go ahead and get this done, and then we'll keep working on it tomorrow once we get this done. Okay, so the question is, why do we have... Yeah, okay, so the question is... Yeah, but it's weird that yesterday we had 25 people watching, and today we have literally the square root of that. You know? Like... Huh. Oh well, that's how it is sometimes, I guess. But... Huh. Okay, that's okay. I'm not going to worry about it. So do L check is equal to p naught j, insert p naught begin L of I. Okay. So what I want to do then is figure out why this is returning an iterator, and I don't know exactly why it would, because it should be returning Let's see. No one is a jerk. You're trying to push back an iterator rather than a vector. No, I'm pushing back. L-check is a vector. It is definitely a vector. It is a vector of integers. But for some reason, I don't know why this guy. Wait, it returns an iterator. Insert doesn't return an iterator, does it? No, we just checked that. Insert does not return an iterator. We totally just checked that a second ago. Right here. Right? If it returned an iterator, then after inserting here, I'm using G++. Pop down here. Okay. So what do we want to do? Maybe you're right. Maybe we just need to do. What if we do p-not.insert here? And then we just push back p-not of j. Okay, that did it. You're right. My bad. Okay, so the issue here was, I'm actually not sure why C++ would do this, but okay. So for some reason, what I was trying to do was I was trying to create a vector to, I don't know why a .insert command would return an iterator. That doesn't make any sense to me, because honestly that seems like it could just lead to bugs. But whatever, this is fine. So let's go ahead and check this function out. Go up here to the top, and let's go ahead and do worstsort. Okay, so we have 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. Okay, good. So we have all the lists. Everything is good to go from there. So now what I'm going to do, I'm going to go ahead and get rid of these guys in here. Okay, so now we have to actually do the worstsort function. This one's going to be a little bit complicated, but that should be okay. So let's go ahead and do that. So let's go ahead and grab this, pop it down to the bottom, and let's see what we got. Okay, so it's called multi-level sort in the paper, but it's relatively straightforward what we need to do here. So let's go ahead and, I mean, I don't know, it might be hard, it might not. We'll see. And once we get this done, I'm going to go ahead and call it for the day, because we're mostly done with this. Just have to do the visualization tomorrow, and that should be that. So I appreciate you guys coming in, and we can go from there. Again, I'm surprised. Sorry. I hope I didn't. Man, my voice is going. I am surprised. Rather, I am surprised that at the viewer numbers, but I'm not worried about it. So don't sit here and think like I'm sad or depressed or anything like that. I'm not worried about it. Again, this channel is basically just a way for me to do things for my YouTube channel and stuff like that. So in the end, it's okay. You know, like, it's fine. I was just expecting, I don't know, I think this is kind of cool. I think this is a neat little algorithm. It's pretty crappy, but it's a neat little algorithm. So this is what we're going to do. We're going to say, oh, we have to create a separate bubble sort algorithm too. Crap. Okay, so what if we do worst bubble sort? We could do that. Okay, so let's see, what do we need to do here? So let's go up to the top. Thanks. So let's see, what do we do? Less than A and B, vector of integers. Let's go up to the bubble sort. Let's see, what do we have here? Well, cool, Techless, thanks for coming in. So let's see, bubble sort here, frame animation, vector integer array. Let me think. So what we're reading in here is a single array, and this array, so what we need to do then is create a bubble sort that reads in a vector of vectors, I suppose? A permutation? Yeah, I suppose that's right. Yeah, okay, fine. So I guess we need to read one in. Gosh, I really don't like this at all. It is like the worst. But I guess we'll just do it. We'll do it. So we need to create a separate bubble sort here. So let's do, I guess we'll put it down here, void bubble sort. And this is going to be reading in frame anim. And then we need to do std vector. Oh my gosh. Of std vector of integers. And we're going to say this is going to be called ampersand array. And I just realized, guys, I need to put ampersands on all of these guys. I have been failing to do that. Ampersand here. ampersand there. There should be some other stuff down here. Yep, right there. And I think down here is already set. So let's go up here to the top, and let's go ahead and add in the ampersands here, and there, and down here. Okay, so now let's go down to bubble sort. Let's go ahead and yank and paste and change this to a vector of ints, and we'll go from there. Let's do vector of int. That should be right. Okay, good. So let's pop down here, make sure I have that right. So let's go up to bubble sort. I was not how to spell bubble. Bubble. Okay, let's go here. Bubble sort there. Okay, vector of integers. Good. Okay, so let's pop down here. And that wasn't what I meant to do either. Good. So the sort's going to be basically the same. There's like no difference between one sort and the other sort. However, I'm going to, in this case, change things up a little bit. So I'm going to say for size t. Let's say I equals 1. Actually, let me think here. Okay, I gotta think. Maybe we're okay with doing the other sort. So what we're gonna have in the end is a list of permutations, right? But each of these lists of permutations, we're going to kind of say is just a list of indices of the previous list of permutations, right? So maybe we're okay with getting rid of, or just using the other bubble sort for now. So let's go ahead and see what we can get away with using the integer bubble sort, and then we'll see if we need to create the vector bubble sorts from there. Okay, so what are we going to say? We're going to say if k equals 0. So this is going to be reading in depth, so we're going to say depth equals 0. Then what we do is we say bubble sort of the array. And I guess we're going to have to also read in anim and the array. Okay. Now with the bubble sort function, we're gonna have to play some tricks. That's okay. Not so worried about that. Okay, so we have the bubble sort of the array. And at this point, it seems okay. So let's pop down here and let's go ahead and do the else statement. Else. Okay, now here's where things get a little bit complicated. So we have to do a multi-level sort on all the permutations. This multi-level sort is going to be the worst sort again. And let me see. So we see that L is a list of permutations. Oh gosh, this is a pain in the butt. Okay, so let me think about this. Oh, this is such a pain in the butt. I might have to leave this one at a cliffhanger, actually. I know we have 20 minutes until 7 o'clock, which is the time I typically end the streams, but I have to think about how I want to get this one done. So we're going to have 1, 2, 3, for example, and then we have to create the list of all the permutations there. So that's going to create a vector of vectors for all the permutations on 1, 2, 3, right? So then what we need to do is read in, we create the list of permutations, and then we do a multi-level sort on that list of permutations. However, yeah, okay, so let's see if we can get this done. So let's pop down here. So let's go up here and let's define everything we need. So we're going to need an std vector of std vector of integer. It's going to be called p. And we're going to say else p is going to be equal to permutation of, and what do we have for permutations? It's just going to be the vector else. So let's go ahead and read in the array. Good. So now we have the list of permutations. Okay. Now what we need to do is create basically a list of indices for the permutations, I think. So, let me see. I suppose we can go ahead and create that here. Yeah, so I guess what I want to do is the following. I want to say std vector Wait. Okay, so each permutation is going to be... Wait, I gotta think about this one. This is not quite what I want here. Okay, so we have a list of all these permutations. Okay, so we have the list of all the permutations. Okay, that's fine. Now we have to sort that list of permutations. So how do we sort that list of permutations? Well, we choose to use worstsort to sort the permutations. Okay, so we'll read in the list of permutations there. Oh yeah, this should be okay. So we're going to do a vector, and we're going to call them elements, or not elements, but we'll call them SD vector of integers. This is not what I wanted. Int, and this is going to be called not elements, but indices, or index, I suppose. And what we're going to do is we're going to make this of size p.size. Okay. Now let's pop down here and let's say for size t I are we already on i's? No, we're not. Equals 0. I less than index dot size. And then we're going to do I plus plus. Pop down here. Now we're going to say index of I is going to be equal to I. Okay. Minus 1. No, I is fine. Okay, good. So now we have the list of indices. So what we just did is create a list of permutations. Then after creating a list of permutations, we went through and we basically turned that into a list of integers, right? So we say, let's go over here. So we say that this permutation, for example, so there are 6 permutations here, right? So we say this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. In actuality, it's, yeah, it might be in this order, I don't know. So this is what we do, okay? And then we sort that list, right? So now we have 1, 2, 3, 4, 5, 6, and then we do the multi-level sort on that list, and this should allow us to continually turn the vector of vectors into a vector of integers, which is more easy to sort. Okay, that should be good, I think. I hope. We'll see. Okay, so let's pop over here. So now we have to do a multi-level sort on the, oops, sorry about that, on the vector of integers. So now we're going to do, worst sort. So we're going to do worst sort. And we're going to need anim, and we're going to need int depth. And then we're going to need, and it should be depth minus 1. We could maybe use an STD map. I'm not actually familiar with these very well. So we'll do that. And then we want array. Oh no, we want index. Oh yeah, I use maps all the time. I use unordered maps. It's not quite like a map, but it's in a way kind of similar. Okay, so then we do the worst sort there. Okay, so now what do? We have all the indices. And then what do we want to copy? We copy, they say P of 1 onto L. Copy the first element onto L. So what we want to then say is array is going to be equal to P of 0. Okay, so does this make sense? What did we just do? Okay, so we basically went in and we said we have a list of 1, 2, 3. Okay, so we have all these guys, okay? Yeah, I think this does it. I think this does it. Okay. So I believe this is okay. Okay. Let's just go ahead and make it. Okay, so now the problem here is how do we do the visualization? And that's going to be a bit of a pain because here's basically what's happening. We have some sort of initial array. This initial array spawns, you know, n factorial other arrays, and those each spawn n factorial other arrays, and those spawn n factorial other arrays, and basically they just keep spawning more and more arrays until eventually we have this huge map or this huge list of arrays, none of which are particularly useful. And then we sort each one until they're all gone. Yeah, that's basically what we do. Yeah, okay. So I think I have a way to do this visualization. I think that's okay. But for now, what I think I want to do is I want to just go ahead and commit what we have right now to GitHub, and then I'm going to go ahead and close today's stream. And I realize it's a bit of a cliffhanger, but the visualization is going to take some time, and I need to kind of think about the best way to do this. And rather than doing what I did yesterday, where I just kind of tackled a sorting algorithm that I wasn't quite familiar with, I think it's better just to go ahead and end today's stream now. And I realized, sure, that we started a little bit late and we're ending a little bit early and yada, yada, yada. But hey, I'm sorry, okay? Like, it's the holidays. I actually have today off, and so I want to spend today making my next YouTube video, getting everything set so that we can have everything but this visualization, and then we'll finish this visualization on stream tomorrow, and then we'll be done for this video and probably the new year. So I'm pretty happy with that. One thing I do want to point out, I realize maybe we don't have too many people watching today, but that's perfectly okay. Again, we've been doing a whole bunch of stuff on this channel. You know, like we've been getting quite far, and I'm quite happy with what we've done in 2016. So even if 2016 might have been a crappy year worldwide for a number of different reasons, I'm actually quite happy with how far this channel and my YouTube channel have progressed this year. So I'm quite happy with it. So hopefully everything will be will be great in the new year. Again, I don't intend to quit streaming or quit making YouTube videos or anything like that anytime soon. So anyway, guys, thanks so much for coming in. I'm going to go ahead and uncomment some stuff, and I guess we're just going to let this guy, we're just going to commit this guy to GitHub, and we will be good to go from there. So let's go ahead and right quit. Git status dot. Looks like it's just worstsort.cpp. So let's go ahead and do, did I change anything in the visualization? Let's go ahead and do git status visualization Cairo. And then we're going to do Cairo visualization. Let's just do Cairo. Visualization test? One second, let's do a git diff. Visualization. Oh, that's the executable. I don't care about that. So let's do git add worstsort.cpp. And now let's do git commit -m. Adding in the worst sort algorithm. And fixing bubble sort. Visualization to be done tomorrow. Okay, so now let's do git push origin master, and you guys should have access to this in just a second. Again, guys, if you don't know where to find this, just basically go to my channel, scroll down a little bit. Let's see, where is it? It should be here in info. Scroll down and go to, I don't know, there should be something like GitHub down here. Here it is, GitHub right here. Here's a link in here. Feel free to take a look. Yeah, I'm glad you're learning something when you're here, Lost Center. I mean, that's kind of the point. And I think that is it for today. So guys, thank you so much for coming in. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos, when we do the visualization of the worst sort algorithm, which will look quite bad, but that's kind of the point. I really like this. The worst sort is awful, but I find it actually quite fun. You know, like this is one of the, I think, weirdest simulations we've ever done on this channel. We've done a whole bunch of weird simulations. Anyway, guys, thanks again for coming in, and I will see you guys tomorrow. Bye, guys.